Long before the echo of human footsteps resonated on Earth, the landscape was a battleground of survival. Massive predators like the Tyrannosaurus rex and colossal marine reptiles ruled the skies and seas, while in their shadows, unseen and nearly forgotten, tiny parasites thrived. These insidious creatures, ticking like a hidden clock, embody a fascinating chapter of our planet's ancient history, revealing survival tactics that have long evolved but remain relevant today. Among these creatures was the tick, a stealthy bloodsucker that clung tightly to its unsuspecting hosts. With their ability to lie in wait for days, they embody patience, biding their time until the perfect moment to strike. Once attached, they inject saliva that not only numbs the area, but also helps evade the host's immune response. This ancient art of stealth has been perfected over eons, showcasing nature's incredible ingenuity, even in the smallest of forms. Fleas, too, played a pivotal role in this brutal age. Though small, they were fierce. Their incredible jumping ability allowed them to traverse vast distances, hopping from creature to creature in search of blood. Their rapid reproduction rate ensured that even the harshest environments could not suppress their population. These miniature warriors had evolved to exploit the very survival strategies of their hosts, adapting finely to life amid colossal beasts, crafting a narrative of resilience that still resonates today. Equally intriguing are the lice, tenacious and utterly devoted to their hosts. They embarked on a parasitic journey alongside various species, embedding themselves in fur, feathers, and skin, ensuring their survival even as their hosts changed and evolved. Their fossil traces serve as keen reminders of the past, shedding light on complex symbiotic relationships that emerged during the age of dinosaurs, hinting at how these ancient parasites learned to navigate their perilous worlds. As we delve deeper into this prehistoric realm, we uncover not just the remarkable adaptations of these bloodsuckers, but also their impacts on host species, shaping the course of evolutionary history. Each bite tells a story, a tale of both suffering and survival, woven into the fabric of life, long before humans emerged. The effort of these ancient parasites reminds us of the world's intricate balance, where even the smallest beings play pivotal roles in the grand saga of life. In a vast world where dinosaurs presided as the ultimate rulers, the land echoed with the thunderous steps of colossal herbivores and the predatory roars of fierce carnivores. Yet amidst this grandeur, an unseen drama unfolded. Small, nearly invisible parasites thrived in the shadows, adapting and evolving alongside their much larger counterparts. These tiny foes offered a chilling reminder of nature's intricate tapestry, where even the mightiest could be vulnerable. Imagine a towering brachiosaurus, grazing leisurely on an expansive canopy of leafy greens. Unbeknownst to it, a fleet of ticks crept silently along its thick skin, needles poised and ready to pierce. Each tick, a master of stealth, fed on the massive herbivore's rich blood. Despite its size, the brachiosaurus was not invincible. These tiny predators could weaken even the greatest giants when they accumulated in numbers. They epitomized survival in a world where every creature, no matter how large, faced challenges from the tiniest of beings. Meanwhile, the air filled with the growls of an apex predator as a Tyrannosaurus rex scanned its territory for prey. Its powerful muscles rippled beneath its skin, but hidden within the crevices of its scales were distorted shadows of a different kind: parasitic fleas. These minuscule parasites clung tightly to their formidable host, drinking in nourishment while risking exposure to the blunt force of its powerful jaws. The fierce predator, embodying terror, wore a burden often overlooked. It lived its life under constant siege from parasites that thrived in symmetry. The interactions between dinosaurs and parasites illuminate a remarkable truth about ecosystems. The very fabric of life was woven with connections both obvious and understated. While herbivores nurtured immense growth in their surroundings, parasites played a crucial role in controlling populations and maintaining balance. They acted as indicators of a creature's health and vitality, warning of shifts within the ecosystem long before other signs became apparent. These ancient interactions serve as a reminder that every layer of life has its purpose, from the awe-inspiring giants to the minuscule marauders that preyed upon them. In this realm governed by dinosaurs, parasites were not mere observers. They were essential players in the evolutionary game. Their existence challenges us to reconsider the dynamics of power and vulnerability in nature, reminding us that oftentimes, the smallest creatures can have the largest impact. This balance, intricately connected, would shape ecosystems long before mammals emerged as the new dominators of Earth. Understanding this hidden landscape encourages a deeper appreciation for all life forms, from the colossal to the inconspicuous. The story of parasites unfolds like an ancient tapestry, woven with threads of survival and adaptation. Long before the lumbering dinosaurs roamed the Earth, parasites thrived in the shadows of life. Fossils reveal that even during the Mesozoic era, over 100 million years ago, tiny creatures such as ticks and fleas had already embarked on their life-sustaining quest for blood and sustenance. These diminutive bloodsuckers, barely noticeable amidst the grandeur of prehistoric landscapes, likely shared habitats with early reptiles and amphibians. Picture a scene where the lush ferns and towering conifers provided shelter for these early creatures. It is within this verdant theater that parasites lived, strategically positioned to latch onto unsuspecting hosts. The early interplay between parasites and their hosts was a silent dance of survival, one that would shape countless ecosystems. As time marched on, the age of reptiles dawned. The magnificent dinosaurs took center stage, reigning supreme over the Earth. Yet even they were not immune to the relentless grip of parasites. Imagine the great Triceratops roamed the dense forests, blissfully unaware of the microscopic intruders clinging to its skin. These parasites found a perfect feast, exploiting the very size and strength of their colossal hosts. This relationship exemplified the remarkable adaptations parasites made through time. Through sheer resilience and cunning, parasites refined their tactics, evolving in ways that ensured their survival. They became expert mimics, sometimes disguising themselves among the flora and fauna. Some even developed complex life cycles that involved multiple hosts, showcasing nature's ingenuity. This evolution did not just affect the parasites, it influenced their hosts as well, driving them to develop defenses and immune responses to ward off these persistent invaders. The narrative of parasites is a testament to the concept of coexistence and competition in the natural world. As environments shifted and life forms evolved, parasites maintained their presence, ever adapting to survive. Today, we see their legacy etched in the many species that inhabit our planet, a reminder that life thrives in diverse forms. From the distant past to the present, parasites have carved out their niche in the grand tapestry of life. They remind us of the intricate connections that exist within ecosystems and the struggle for survival every organism faces, showcasing nature's relentless power and adaptability. Amber fossils serve as extraordinary time capsules, offering a glimpse into a world long gone. These golden-hued gems of nature are not just beautiful, they encapsulate fragments of ancient ecosystems, preserving life forms in a stunningly intricate manner. Imagine discovering tiny creatures like ticks and fleas, perfectly lodged within amber, seemingly frozen in a moment that stretches back millions of years. Each specimen reveals a story of survival, adaptation, and the fragile nature of life on Earth. What makes amber fossil finds particularly remarkable is the level of detail observed. The exquisite preservation allows scientists to examine even the most minute characteristics of these ancient insects. Imagine a flea, its delicate body suspended in time, each facet of its tiny legs captured in incredible clarity. Researchers can analyze the physical structures that were once thriving in prehistoric jungles, offering insights into their behaviors and ecological roles. The amber acts as a protective shield, keeping the organisms untouched by the ravages of time, akin to a window into another era. The allure of amber takes a fascinating turn, with the discovery of creatures still clinging to their hosts. Picture a tick, securely fastened to a dinosaur's feather, both encapsulated in a golden glow. These ancient bloodsuckers not only provide evidence of their existence but also hint at the complex relationships between species of the past. Even more astonishing, some ticks have been found containing dinosaur blood, a finding that sparks the imagination and poses questions about the ecosystems that once teemed with life. What interactions occurred between the host and the parasite? How did these life forms navigate their environment? As scientists delve into the study of amber and its contents, they unlock secrets that have remained hidden for eons. The intersection of paleontology and modern science allows us to appreciate the beauty and complexity of ancient ecosystems, paving the way for potential advancements in genetics and disease research. By studying the preserved DNA within these ancient specimens, researchers hope to unravel the mysteries of evolutionary biology. Amber fossils are not merely relics. They are a treasure trove of knowledge, urging us to further explore our planet's history and the life it once harbored. In a remarkable find, a tick preserved in amber has captured the imagination of scientists and enthusiasts alike. This tiny creature, once clinging to the feathered plumage of a dinosaur, offers a window into a long-lost world, connecting us to an age when majestic beings roamed the earth. Imagine the vibrant jungle where this tick thrived, swaying on the feathers of its host, a moment frozen in time that reveals the intricate web of life that existed millions of years ago. The discovery tantalizingly suggests that ticks were not merely products of modern ecosystems, but rather ancient survivors that have existed since the age of dinosaurs. These wingless parasites, adept at exploiting their hosts, have evolved alongside their prey. Visualize this tiny tick with its hard, glossy exterior, nestled among the fine, downy feathers of its ancient host, navigating both the perils and abundance of a primeval forest. It paints a picture of evolution's relentless march and the tenacity of life. Ticks and fleas, despite their diminutive size, play crucial roles in their ecosystems, acting as vectors for diseases and opening doors to understanding the relationships between species. The preserved tick embodies the resilience of these creatures, attesting to their successful adaptations over countless generations. Envision a world seen through the eyes of this tick, thriving in environments shaped by towering dinosaurs, intricate flora, and shifting climates, a testament to nature's ingenuity. Such discoveries prompt inquiries into the evolutionary pressures these parasites faced. How did they adapt to the different hosts and climates over millions of years? Each amber-encased specimen holds secrets waiting to be unraveled, hints of complex interactions within ecosystems that have come and gone. Picture the ecosystems these ticks inhabited, evolving side by side with the rise and fall of dinosaur species, each adapting and thriving in its niche. This captivating insight into the relationship between ticks and their hosts enriches our understanding of biodiversity through eons. As we marvel at this minuscule marvel, let us appreciate the grand tapestry of life it represents. The feathered dinosaur that hosted this tick was part of a vibrant, interconnected web of life, making us ponder not only the past but the intricate paths that connect us all. In the end, the discovery of a single tick has illuminated a rich narrative, intertwining the threads of past and present, evolution and survival. Ticks, ancient as time itself, have thrived for over 200 million years, making them one of Earth's most persistent parasites. Their survival through epochs reveals a remarkable resilience, evolving alongside colossal creatures that once roamed the land. Imagine a world where the titanic form of a sauropod looms, its long neck stretching toward the treetops, unaware of the minuscule menace lurking nearby. Ticks, with their bead-like bodies and 8 nimble legs, belong to a lineage that predates many mammals, silently waiting for their opportunity to draw blood. As giant sauropods grazed on lush vegetation, the environment teemed with life, creating an intricate web of ecological interactions. Ticks capitalized on this abundance, using their finely honed instincts to detect carbon dioxide and heat emitted by potential hosts. Picture lush ferns and towering conifers swaying as these massive beasts moved through their habitat. It was an era rich in opportunities where ticks would perch upon blades of grass or the lower branches of trees, stealthily poised to leap onto unsuspecting giants. Once on board, these enterprising parasites employed an extraordinary feeding strategy. Ticks possess specialized mouthparts known as hypostomes, which latch onto their hosts, allowing them to anchor securely while they feed. Visualize the scene: a tick, perfectly camouflaged among rough skin or dense fur, seamlessly navigating the massive contours of a sauropod. Their saliva, laden with anticoagulants, ensures blood flows freely, turning each feeding session into a seamless and prolonged affair. As they satiate their hunger, ticks tap into a pivotal survival tactic. They consume small portions over extended periods, minimizing the chance of detection. Furthermore, ticks' ability to endure harsh environmental conditions speaks volumes about their evolutionary adaptations. Capable of withstanding temperature extremes and periods of starvation, these ancient parasites are a testament to survival. Imagine the tick's journey through time, surviving ice ages, climate shifts, and changing landscapes, all the while sharpening their feeding skills and resilience. It's a tale not just of survival, but of thriving in a world dominated by giants. In conclusion, the story of how ticks fed on magnificent sauropods is not just a biological curiosity. It is a vivid narrative of evolution, adaptation, and persistence. As we study these ancient parasites, we glean insights into the complex ecological relationships of the past, illuminating the mysterious interplay of life that still resonates in our world today. Ticks, with their ancient lineage, remind us that survival often lies in the smallest of beings. Imagine a prehistoric landscape where massive dinosaurs roamed freely under a scorching sun. Among the towering ferns and vibrant flora, tiny but formidable creatures lurked, ready to embark on a gruesome feast. Ticks, with their specialized mouthparts, were perfectly adapted to pierce the tough skin of these colossal hosts. They knew exactly where to latch on to maximize their feeding. As the tick sank its mouthparts into the skin of a dinosaur, it deployed a cocktail of chemicals designed to prevent the blood from clotting. This slimy substance acted like a magical elixir, ensuring a continuous flow of nourishment while the tick feasted on the dinosaur's blood. Days turned into weeks as the tick sat, utterly unconcerned, enabling it to grow and thrive while minimally impacting its massive host. The sheer size of the dinosaur presented unique challenges, but also innovative opportunities for the tick. With some dinosaurs sporting thick, leathery skin, these parasites had to be clever in their attack methods. They would find tender spots hidden among the bony structures, all while navigating the scale-covered landscape of their unfortunate meal. In a delicate dance of survival, ticks would ensure they remained undetected, allowing them the luxury of time. Once attached, the tick essentially became a silent partner in the dinosaur's ecosystem, feeding hand in hand while hidden from sight. As the dinosaur lumbered through its daily routine, the tick continued to draw sustenance, sharing in the riches that its larger host provided. Even in this symbiotic relationship, one has to wonder if the dinosaur ever sensed the tiny parasite feeding on its lifeblood. In a world dominated by giants, these minute marauders played a crucial role in the ancient food web. Their ability to latch on and extract blood allowed them to thrive in conditions that would have overwhelmed lesser creatures. They were predators in their own right, small yet steadfast, their ancient lives intertwined with the giants of the past. So, the next time you gaze upon a dinosaur fossil or an exhibit showcasing these magnificent creatures, consider the ticks that may have once shared their world. Even in the ancient past, the cycle of life continued, both grand and minuscule, in a complex tapestry of existence that shaped our Earth long before humankind. Fleas, a remarkable testament to nature's adaptive prowess, have occupied our planet for millions of years. Emerging in ancient epochs, these tiny bloodsuckers have evolved a sophisticated arsenal of survival mechanisms. Their powerful legs, finely tuned for leaping, are a marvel of evolution, enabling them to spring onto their unsuspecting hosts with incredible agility and speed. In the realm of prehistoric ecosystems, Fleas were not merely nuisances but formidable competitors. They thrived alongside colossal creatures with their sizes likely dwarfing the minuscule pests we encounter today. These ancient fleas had to be resilient and aggressive, honed to pierce even the thick skin of imposing mammals. Their existence was a dance of predator and prey, a relentless struggle for sustenance. As they sailed through the ages, prehistoric fleas adapted further to their environments. The vast and diverse habitats provided unique challenges, demanding not just strength but also agility and cunning. Their pronounced jumping ability allowed them to traverse the vast Atlantic expanse or the forests filled with towering foliage. This gave them a competitive edge, ensuring they would find their hosts amidst a world full of colossal competition. Survival strategies of these ancient fleas were compelling. Their ability to reproduce rapidly ensured their lineage thrived even in the most tumultuous conditions. Each leap onto a warm-blooded creature marked not just a meal, but a moment in their relentless quest for survival. With each bite, they carried forward the legacy of being one of nature's oldest and most efficient bloodsuckers. The relationship between these fleas and their gigantic hosts was multifaceted. While the hosts provided sustenance, the fleas improved their hosts' resilience by driving natural selection. Those that housed fleas were more likely to develop defenses against parasitic feeding, which in turn shaped the evolution of both creatures. That interplay forged a unique bond throughout the annals of history. Today, we often regard fleas as mere pests, yet their prehistoric ancestors remind us of nature's complexity and resilience. The endurance of fleas through epochs, adapting to myriad changes, showcases not just a tale of survival, but an intricate interconnection among species. Those ancient bloodsuckers continue to intrigue scientists, as they exemplify the wonders of evolution amid the colossal giants they once called home. In the grand tapestry of evolution, the battle between parasites and their hosts paints a remarkable picture of adaptation and survival. As ancient dinosaurs roamed the earth, they faced not only the challenges of predators and changing environments, but also the insidious threat of tiny invaders, parasites. These organisms, like fleas and ticks, were an ever-present danger, prompting an intricate dance of evolution where hosts evolved defenses to repel these unwelcome guests. Dinosaurs, colossal yet vulnerable, began to develop unique physical features to protect themselves. The emergence of feathers among some species was not merely for display or warmth, but also served as a barrier against parasites. These feathery shields could obstruct parasites' access, creating a difficult environment for them to thrive. Similarly, the evolution of thick, tough skin among certain dinosaurs made it harder for parasites to penetrate and attach. These adaptations underscore the lengths to which hosts would go to ensure their survival in the treacherous game of life. However, nature thrives on challenges, and parasites are masters of counter-adaptation. Fleas, for instance, refined their ability to leap with exceptional agility, developing long legs that enabled them to jump onto their hosts swiftly. This newfound skill dramatically increased their chances of survival, showcasing the relentless pursuit of adaptation. Moreover, ticks engaged in their own evolutionary innovations, evolving specialized structures that allowed them to hide seamlessly within the crevices of their host's skin. This cunning strategy enabled them to remain unnoticed for days while they feasted on their host's blood. The ongoing duel between hosts and parasites is a testament to the power of adaptation. As hosts develop new defenses, parasites continually refine their strategies to outsmart and infiltrate. This relentless cycle of evolution has shaped and reshaped countless species, driving diversity and innovation in the natural world. The intricate relationship between dinosaurs and their parasites underscores nature's complexity, revealing how each adaptation triggers a ripple effect in the evolutionary landscape. In summary, the interplay between parasites and their hosts exemplifies the tenacity of life on Earth. While dinosaurs evolved remarkable defenses like feathers and thick skin, parasites like fleas and ticks quickly adapted, showcasing the dynamic and competitive nature of evolution. This ongoing battle for survival not only illustrates the wonders of adaptation, but also the immutable cycle of life itself, where each generation learns and evolves in response to the challenges posed by its environment. Throughout history, the natural world has witnessed a relentless evolutionary arms race, a dynamic competition between hosts and parasites. Imagine the fierce struggle each time a dinosaur flexed its newly acquired physical traits against the unseen threats lurking within its own ecosystem. As these ancient behemoths evolved impressive defenses, like armored skin or sharpened spines, their adversaries, the parasites, responded with equally remarkable adaptations, striving for survival in a dance dictated by necessity and innovation. This back-and-forth conflict is fueled by various environmental pressures. For instance, the emergence of a tough, scaly hide in some dinosaurs was a profound evolutionary step, aiming to thwart parasitic infections. However, in the shadows, parasites began to develop specialized mechanisms to breach these defenses. Some evolved advanced techniques for attachment, while others developed toxins that could weaken their massive hosts. Each innovation led to another countermeasure, creating a battlefield where survival hinged on adaptation. In this ongoing saga, the migration of ideas from the past to the present highlights the universal nature of evolutionary challenges. Fast forward to contemporary ecosystems, and the echoes of these ancient struggles resonate even today. Modern wildlife demonstrates that the game remains unchanged. Think of the nimble gazelle that outpaces lions while also developing resistance to biting insects. It creates a vivid picture of species battling against potential extinction with every leap and bound they take, expertly aware of the threats that challenge their existence. Moreover, the arms race extends beyond mere physical adaptations. Behavioral changes often play a critical role. Some species exhibit heightened vigilance or use strategic social structures to combat the ever-looming threat of infection. They communicate and adapt to the behavior of parasites as effectively as they maneuver around predators, painting an intricate picture of survival through collaboration and learning. In the grand tapestry of life, each thread woven through countless years tells a story of struggle, adaptation, and ultimate survival. The concept of an evolutionary arms race reminds us that nature's canvas is ever evolving. The relationship between host and parasite, predator and prey, continues to inspire awe, illustrating a delicate balance that defines the complexity of life on Earth. This dance of evolution is not merely a historical phenomenon. It is a modern-day reality, continuing endlessly as organisms vie for dominance in an intricate web of life. Fossils serve as remarkable portals to our planet's ancient history, offering glimpses into environments long vanished. Among these treasures, amber stands out like a shimmering time capsule. Formed from the hardened resin of ancient trees, amber has captured not just plant matter but also an astonishing array of life that once thrived millions of years ago. The allure of amber lies in its ability to entrap organisms, preserving them in exquisite detail. Imagine a tiny mosquito, its delicate wings frozen mid-flight, or a minute spider poised to ensnare its next meal. These preserved specimens allow scientists to study the intricacies of prehistoric ecosystems, revealing relationships and behaviors that would otherwise remain hidden. Among the most intriguing inhabitants of amber are parasites, ancient bloodsuckers that once feasted on the blood of their hosts. The details are stunning. A gnat with a long, slender mouthpart poised for a meal, or a tick nestled within the fur of a now extinct creature. The study of these parasites sheds light on evolutionary adaptations and changes in host-parasite dynamics over eons. Moreover, amber serves as an exceptional preservation medium. The resin's chemical composition inhibits decay and protects the organisms within. Contrary to the ravages of time that other fossils endure, those encased in amber retain color, structure, and even traces of soft tissue. This exceptional preservation provides a rare opportunity for paleontologists to analyze the microscopic attributes of ancient life forms. The extraction and study of these specimens not only illuminate the biological tapestry of the past, but also stir the imagination. What were the environmental conditions that allowed these creatures to thrive? How did ancient ecosystems adapt? Questions like these fuel ongoing research, as scientists meticulously analyze and even reconstruct dormant chapters of life hidden in the golden depths of amber. Amber fossils remind us that nature's artistry knows no bounds, capturing moments that in life were fleeting. Each inclusion is a story waiting to be told, a connection to an era where creatures roamed and interacted in ways that are beyond our present-day comprehension. They inspire a deep appreciation for our planet's history and the connections that bind us to those who walked before. In conclusion, the tale of amber and its remarkable fossils continues to unfold. As we delve deeper into this ancient treasure chest, we are likely to uncover even more wonders, expanding our understanding of life on Earth and its ever-evolving narrative. Imagine a moment cozy within the heart of a prehistoric forest, where the air buzzes with life and ancient plants stretch toward a dimly lit sky. Nestled within a glistening amber droplet, an ancient flea lies perfectly preserved, a snapshot of an era lost to time. This remarkable fossil, discovered within the amber dating back nearly 120 million years, reveals a fascinating intersection of evolution and the natural world. Upon observation, its elongated body is framed by intricate details, each curve and contour whispering stories of its resilience in a dynamic ecosystem. The powerful legs, built for remarkable agility, resonate with a primitive energy. This flea was not just a mere nuisance, it was a formidable jumper, perhaps able to leap great distances. Its hypothesized ability to jump might suggest a strategy to attach itself to smaller mammals or even majestic dinosaurs roaming the earth, seeking a warm refuge and a source for sustenance. As we delve deeper into this remarkable find, we uncover the potential lifestyle of this prehistoric flea. Imagining it bounding through ancient underbrush, the flea would have navigated the dense foliage with incredible speed, darting to evade predators and seeking hosts. Equally thrilling is the realization that this tiny creature played a role in a larger ecosystem, perhaps serving as both a parasite and a concurrent link between species that roamed the Earth millions of years ago. The context of this flea fossil, encased in amber, adds another layer of mystery to its story. This ancient tree resin, capable of preserving minute details over epochs, provides a glimpse into an intricate web of life that thrived during the Cretaceous period. It preserves not just the flea, but often leaves and insects, allowing paleontologists to piece together ecological dynamics of a world that is profoundly different from our own. In this beautifully petrified bubble, life is encapsulated, frozen at a moment when the world was a thrilling canvas of biodiversity. Each specimen discovered, like our flea, enriches our understanding of evolution and adaptation, reminding us that the small and seemingly insignificant have always played a pivotal role in the grand narrative of life on Earth. As we gaze upon these remnants of a bygone era, we are compelled to ponder the myriad stories hidden within nature's amber treasures, waiting patiently to share their ancient tales. As the reign of the dinosaurs came to an abrupt end 66 million years ago, the world witnessed one of the most significant mass extinctions in history. This cataclysmic event not only reshaped the landscape of life on Earth, but also posed monumental challenges to various organisms, particularly parasites that had thrived alongside their colossal hosts. In the shadows of this great extinction, many parasites faced a grim fate, teetering on the brink of extinction themselves as their primary food sources disappeared almost overnight. Yet, nature has a remarkable way of adapting, even in the direst circumstances. While countless species perished, some parasites exhibited extraordinary resilience. These survival artists pivoted their life strategies, seeking refuge in the emerging lineage of early mammals. This transition was not merely a survival tactic. It marked a significant shift in the evolutionary relationships between hosts and parasites. As early mammals began to fill the ecological niches left vacant by the dinosaurs, the resilient parasites seized the opportunity, migrating and evolving alongside their new furry hosts. The unique adaptations of these parasites highlight the dynamic and often precarious relationships found within ecosystems. With traits honed by millions of years of coevolution, these parasites evolved specialized mechanisms to thrive within their new mammalian hosts. Some developed intricate life cycles, emphasizing stealth and precision, while others produced biochemical tools to manipulate their hosts' immune systems, ensuring their survival and propagation. This intricate dance of survival forged new relationships, uniting hosts and parasites in a complex web of dependence and adaptation. In the backdrop of this turbulent era, the world transformed dramatically. As forests regrew and new species emerged, the adaptive prowess shown by these parasites played a crucial role in shaping mammalian evolution. They not only influenced the health of their hosts, but also contributed to the diversification of mammalian species, leading to the rich tapestry of life we see today. Thus, while the dinosaurs might have dominated their time, the hidden story of their parasites persists, a testament to the resilience of life and the unending pursuit of survival against the odds. The extinction of the dinosaurs marked an extraordinary turning point in Earth's history. While the mighty reptiles disappeared, a different kind of survival unfolded in the shadow of their demise. Blood-sucking parasites, which had thrived alongside dinosaurs, shifted their adaptation strategies as mammals rose to prominence. This era was not an end, but rather a transformative phase for these resilient organisms. Evolution kicked into high gear as mammals began to seize the ecological roles once dominated by dinosaurs. With this shift, parasites such as ticks and fleas embarked on a journey of adaptation. No longer able to cling to their original hosts, these parasites sought new blood. The fur of mammals became an inviting habitat, the perfect new territory, and a vital resource for sustenance. The anatomy and behavior of ticks and fleas evolved in response to this new landscape. As mammals varied in size and habitat, from burrowing critters to majestic creatures roaming the plains, parasites fine-tuned their feeding strategies. Ticks, with their knack for climbing, became expert hitchhikers, patiently waiting on blades of grass to attach themselves to unsuspecting hosts. Fleas, on the other hand, honed their jumping abilities, making them agile predators in search of blood meals. These adaptations fostered unique biological relationships between mammals and their parasites. Mammals provided not only sustenance but also environments where parasites could reproduce and thrive. In this new ecological balance, diseases carried by these parasites began to emerge, intertwining the destinies of hosts and their bloodsuckers. This synergy, however troubling, led to the resilience and diversity of parasitic life forms in the world. As this evolutionary tale unfolded, the complex dynamics in ecosystems became increasingly evident. The presence of blood-sucking parasites expanded their influence on mammalian populations, shaping behaviors and health dynamics. Commensalism, where both organisms benefit, and parasitism, where one thrives at the expense of the other, marked the dual legacy of survival and struggle that characterized this epoch. The intricate dance between mammals and parasites played a noteworthy role in the development of modern ecosystems, testifying to the enduring adaptability of life in its various forms. Parasites proved that the extinction of one group did not lead to the eradication of all. Instead, they serve as a reminder that in the game of survival, adaptation reigns supreme. Today, the story of blood-sucking parasites continues to unfold, illustrating the tenacity of life against changing backdrops. Ticks and fleas have woven their existence into the tapestry of life for millions of years. Intrinsically linked to their hosts, these tiny creatures thrive in various environments, showcasing a resilience that seems almost supernatural. The ancient origins of ticks and fleas date back to primitive times, where they mastered the art of survival, coexisting with dinosaurs and evolving alongside mammals. Their blood-feeding habits enable them to adapt to changes in climate, habitat, and even host species, allowing them to flourish in modern ecosystems, including our own homes. The anatomy of these pests reflects their evolutionary prowess. Ticks, cloaked in armor-like exoskeletons, possess specialized mouthparts that anchor them firmly into their hosts, allowing them to extract blood with ease. Fleas, on the other hand, are masters of mobility. Their powerful hind legs enable aerial feats, allowing them to leap several inches to find their next meal. These adaptations not only ensure their survival, but also render them nearly indomitable in the face of eradication efforts. Despite the human quest to control and eliminate them, their very nature makes it a challenging endeavor. Hosts come in all shapes and sizes, offering a buffet of nourishment for ticks and fleas. From household pets to wild animals and even humans, their ability to exploit their hosts is nothing short of remarkable. The transmission of diseases between hosts is equally alarming. Ticks, in particular, are infamous for being vectors of Lyme disease, warrants careful attention and preventative measures. As they traverse the landscape, their presence serves as a reminder of the delicate balance within ecosystems, where every creature plays a role, even the smallest and seemingly insignificant among us. As we strive to cohabit with these ancient beings, understanding their characteristics and behaviors becomes essential. Knowledge empowers us to take preventive actions, like keeping our pets treated and maintaining clean environments to deter infestations. Furthermore, industry advancements create new solutions in pest control, but the resilience of ticks and fleas calls for ongoing research and vigilance to ensure public health. Appreciating the role of these creatures in our ecosystem, despite their unwelcome nature, can lead to a harmonious coexistence. Parasites have mastered the art of survival, from their primitive ancestors that once thrived on the blood of dinosaurs to their current forms that inhabit our modern world. This astonishing journey showcases not only resilience, but also the relentless drive of nature to adapt and evolve in the face of challenges. These extraordinary organisms began their evolution millions of years ago, entwined with the very fabric of life on Earth. During the age of dinosaurs, they emerged in various forms, developing unique strategies for survival. Some adapted to feed on the vital fluids of their hosts, while others exploited the vulnerabilities of their environmental niche, showcasing an uncanny ability to thrive amidst the colossal reptiles. As the world transformed, so did parasites, navigating the changing landscapes and host organisms. The extinction of the dinosaurs opened new doors, allowing these creatures to diversify and flourish. From the shadows of extinction, they evolved into highly specialized forms, adapting to live and diverse environments, including the human body, where they discovered an endless supply of hosts. The adaptability of parasites is evident in their intricate life cycles, often requiring multiple hosts for reproduction and survival. This complexity has honed their survival strategies, allowing them to evade detection and develop resistance to various means of control. The delicate balance they maintain with their hosts speaks volumes about the evolutionary arms race that unfolds between parasites and the organisms they exploit. In contemporary times, parasites still play a significant role in ecosystems, influencing population dynamics and even driving evolutionary change in their hosts. From the common cold to the terrifying effects of malaria, their impact resonates with every breath we take. These tiny powerhouses can shift the fate of species, demonstrating their pivotal position in maintaining ecological balance. Their story doesn't end here. It is a continuous saga of adaptation, innovation, and survival. With climate change and human encroachment into wild habitats, parasites are poised to face new challenges and opportunities. As we delve deeper into understanding their biology, we uncover the profound implications they hold for medicine, ecology, and the intricate web of life on Earth. In recognizing the tenacity of parasites and their pivotal role in our world, we come to appreciate not just the persistence of nature, but its extraordinary capacity for renewal and survival, proving that even in the face of adversity, life finds a way.